Now for the normal curve. We've been talking about the normal curve for a while. First off, here is a function for it. So if you were to plug it into a graphing calculator or something like that, you'd have this nasty function to deal with. And of course, sigma, mu, there's another sigma, pi. There's a bunch of constants in there. The only variable here is x. But regardless, it's a very ugly function to have to deal with. So as opposed to dealing with that in calculus, we've come up with other methods to deal with the normal curves and find percentages of a population or sample that lie within a region, as well as probabilities. You'll notice the probability notation here. So we could find, if this is the normal curve, the probability that a random variable lies between A and B by simply finding the area under this curve. Now that's usually a calculus topic, the area under the curve between A and B. I can tell you right now, if I was to show this function to either Calc 1, 2, and some 3 students, they'd be scared. They'd be very, very terrified to see this function, something that they have to find the area under that curve. So it's not something we want to deal with. Thus, we try to use tables and other means. First off, a quick example here. If the average score on exam 1 was 78% and the standard deviation was 6, find the percentage of students who scored in the middle 95% of the class. Okay. Now, first off, we're going to assume, as with most of these problems, assume that this is a normal curve or a normal distribution. By assuming that it's a normal distribution, that means that we can use the empirical rule. Normal distributions are bell-shaped and symmetric. So if we're using the empirical rule, we know the middle 95% of the class is going to be within 2 standard deviations of the mean. That is, it's going to be either the mean minus 2 standard deviations or the mean plus 2 standard deviations. That'll give us the middle. Again, middle starting with the 78 or the mean itself, then adding or subtracting 2 standard deviations. Now it's some simple calculation. 78 minus 12 is going to be what? 66. So 66% up to 78 plus 12, 90%. So the scores for 95% of the class were between 66% and 90%. Again, we just had to use the empirical rule for that. How about those that scored in the top 16% of the class? Top 16%. So if we're looking at our standard deviation, here's mu. I'm looking at the top 16%. Okay. If this is 16%, and the area beneath the normal curve, which we've talked about earlier, you can see it's written here as well, is 1. So here we've got 0.16. Under the whole thing we've got 1, meaning that the rest of this should be 1 minus 0.16 or 0.84. Okay. So we've got 84% of the population over here, 16% over here. Again, we haven't yet talked about anything other than the empirical rule. So looking at that, we've got 68% within 1 standard deviation, 95% within 2 standard deviations, and any more than that, that's going to be well over our 16% left over, the 99.7%. That's within 3 standard deviations. So if we look at this, we're looking for this area to be 0.16, meaning we're looking for this number right here, okay, whatever that number is. If we assume that we've got 0.16 over here as well, then all of a sudden our 0.84 is reduced by 0.16, and in here we have 68 or 0.68. So that's one standard deviation from the mean. In other words, the top 16% is greater than one standard deviation from the mean. The top 16% is greater than one standard deviation from the mean. Then that's just 78, the mean, plus one standard deviation of 6. And it looks like the top 6%, top 16% in the class scored an 84% on the exam, or better.